Okay, and hopefully you guys are seeing my screen now. Okay, so to begin, I think we're ready now. To begin, wanted to just give you an overview of what we're going to be reviewing today in relation to evolution. First, we're going to go over the installation, which you should be getting a link in the chat window just momentarily here to download the setup, as long as we get that sent out to everyone. And then we're going to go over the structure of an evolution application, building your first API calls, an introduction to structures in relation to evolution. We're going to go over some pieces of the testing involved with your API, and we're going to show how to use evolution with Apache, and then we're going to go over some basic debugging skills as well. So if you go ahead and download that link that you have there, we can get started on the installation. Now, if you guys have questions, feel free to ask them, interrupt me anytime. This is truly a training session, so if you need me to explain something a little bit better or you know, have questions about the installation or anything, you know, just let me know. Now, for this installation, Evolution will work with Windows Vista and up. So this is something that right now is not going to work on XP, so you want to make sure of that with your development environment. Hopefully, you're set up in such a way that maybe you can either watch or listen and work along on your own machine at the same time. So this installation that we have here is a beta, of course, of just the developer version of Evolution. So we'll talk about what that means in a little bit, but here, let's get started. I'm going to go ahead. Get this downloaded and installed myself. Okay, here we go. So the installation, very basic. You can just go with a typical install. As you can see, it's going to install under the Mertech Data Systems Evolution folder. And for this, you're going to need a VDF installed. The developer version runs, it's meant to run within Dataflex with the debugger running right now is how we're set up to run at the moment for this first beta. And it will work with versions 12 and up of Visual Dataflex. I advise version 15. There's some issues in earlier versions with some bugs that were in Dataflex back then that you can get stuck on. So version 15 and up really works much better. But we're done with the installation now. To show you what's been installed here, we have a quick start guide, which is going to go through a lot of the information that we're going to talk about today. So you have this as a resource to use after our training session today as well. And then there's a package folder, and we'll go over why that's on the menu in just a moment here. So now that we've got the installation done, we have to basically get started with building an evolution application. So I'm going to use Dataflex 18 for this. And we're going to be working with the order entry example. Now, this is just the basic order entry example here. The only thing that I've done in this case is I've converted the database to use the Mertech drivers, and we're connecting to think a Postgres database right now is what we're set up to use. But that's not a requirement for this part of the training at all. Otherwise, this is a fairly standard workspace here. So the first thing that we need to go over in relation to this is the structure of an evolution application. Essentially, your most basic evolution application is made up of simply two files. There's a primary SRC file that basically is how you start your application, and then there's a web object file, a WO file, that contains the service description. So we're going to be working in the order example, and there are a couple of packages that we need, and that's where we come to this piece here. So since we need to use these packages for evolution in our order entry example, for now we've given you a link to where we have our copy of them, and you can just select all of them and copy them and then paste them into your app source folder on your workspace. So now we have those basic files that we need to access evolution. So now we're going to create the two file minimum basically that's required for an evolution application. So first thing we're going to do is create a new basic project. And so we have our default here that Dataflex gives you from their template, and we're going to tweak a couple of things here. Right off the bat, we're going to get rid of some of the help stuff that we don't need. And then we're going to add a couple of other packages we do need. Right off the bat, we need to include dfallint in our sample application for some of the data dictionary support. And additionally, we need to use the evolution.pkg. So after that, we simply create our evolution server object. And we go ahead and we're actually going to, we'll leave that blank for now. And then we're going to start the evolution server. We send on start of oevolution. And this is basically what an evolution shell looks like, is just this. Now, to the shell, we need to add our actual API that we're going to be deploying here. And so in this case, what I'm going to do before I do that, I'm going to go ahead and create a new file. And you'll notice that I said a new empty other file. Since this isn't technically a web project as Dataflex defines it right now, I like to call them .wo files. And of course, our focus today is going to be on the web portion of evolution. So you know, it kind of works well that way. But since this isn't viewed as a true web project in Visual Dataflex, this other file allows us to create a .wo file in a standard project, which is what we're going to do. Oh, let's see here. Oh, that's right. I have to say it's a Dataflex file. So Dataflex source file. Here we go. Okay. So now we're into here. So this is basically where we're going to define our service for evolution, and then we're going to include that service in our evolution server in the main source file. So again, for this, we need to use the webservice.pkg, and then we're going to define an object that is a C web service. Excuse me, a C Evo web service. Here we go. I did that wrong, didn't I? There we go. Okay, and just like in a standard web service, we need to set a service name. So we'll set it to my first service. And then we need to define a function. So for our first call here, we're going to just make a very simple one called test evolution. And we'll have 2 parameters here. And this is one of the functions that we've talked about before that I use just for doing some basic testing. So a very simple function that we have here. Now we need to publish this function. Right now this is just a standard function in DataFlex. And essentially, to make it visible to Evolution, we need to set the attribute just like you would on a standard web service to publish this. So we're going to say published equals true, and now this function will get published. So that's basically all we need to start with for our very first API call. The one other thing we need to do is come in here and use our first evolution, WO. And so that's it. This is our first sample. This is how we're going to test that our installation worked okay, and kind of get into it. So basically, what's happening here is, we define our service that gets embedded into the server, and we tell the server object to start itself. And if you recall, I said that this was all in developer mode. And so this is really dependent on developer mode with the way it operates to kind of get you going real quickly with Evolution. So if I go ahead and just hit play on this, if I made no errors, you'll notice I get the security alert. This is because Evolution is actually exposing a port. So I'm going to go in and just allow all in this case and say allow access. Okay, and now I have a running service. So, what exactly is being exposed here? Well, if I go to command line, and you'll notice I got that firewall pop up, which means that something on my network is listening. One of the easy ways I can tell is to run this command. So basically, netstat -a will show a whole bunch of connections that are on the NIC, and then the find listening is just going to filter that list for us to listening ports only. And so there's quite a bit on this machine that's listening for various items. The one that we're using right now is port 8081. It's this one right here. That's the port that Evolution defaults to. It's normally an open port, and so you can actually go in, right now you have to go into the evolution.pkg file if you wanted to change that to some other port. If we take a look at that here. Right now it's essentially hard-coded in here to port 8081. If you just search the file for it, you'd find it as well. And we can change that in the future. That'll be a little bit more configurable, and a lot of times you don't need to set that at all in here. This is primarily for debug mode that even comes up. So anyways, now we have essentially a running server. So how do we test this to see that this thing is running correctly? Well, one of the other things that we have as part of Evolution, if I go into an Apache folder, basically the Evolution installation through this Apache folder in here, and this is just a standard Windows version of Apache that we've customized a little bit to make it easier to use. So it's set up for us for most things that we're going to need to do here. And essentially, it also has a testing interface that for now is the testing interface we give you to use with Evolution. So one of the, when you go into this Apache folder here, there's a startapache.bat, and this is a fairly smart batch file that will detect what ports are being used on your machine and try and find an open port to run Apache on so you can do this testing. So I could go ahead and start it, but for now I'm going to show you we have a test server up also on evolution.mertechdata.com/API. And this is a tool we're going to talk about a little bit later that is actually really quite useful for testing Json-Rpc calls, which we're going to talk about in a moment also. But let's just do a test to make sure our server is running here. Like I said, we're running on port 8081, localhost, and I think we called our function test evolution. And we're going to pass just two parameters, 20 and 60. Okay, and you can see we got a response here from the server. The result is 80, which is correct, which means that we have a running server. And you can see a couple other details in here about our server. So now that we have the server running, we want to talk a little bit about what Json-Rpc is, and before we dig in deeper to this. So Json-Rpc is a standard that is kind of derived from XML-RPC. So if I go in, I'm going to just show you guys a Wikipedia page on it. And it's been through a couple of revisions. The syntax I used here is actually from an old revision, the version 1.0 revision. But JSON-RPC is this very simple to use interface. When we compare it to XML-RPC, they're very similar, with, of course, the main difference being that we're using JSON rather than XML. And so it's a little bit easier to write, even by hand, tests against this. But when you compare it to some of the other JSON standards out there, so for instance, if we look at what Dataflex has implemented for JSON natively in their web server, you know, we have this sort of amalgamation of JSON and RESTful services where they have basically their own method calling system in place, and you know, that's all their own. Some of it can be done on the URL, some of it can be done in JSON. JSON-RPC is kind of a nice option in relation to some of those because we're using a well-defined standard. So this JSON service can be called, this JSON-RPC service can be called by any JSON-RPC client. There's no tweaking that you have to do. Nothing has to be done custom in that way. It's you know, a well-defined standard. It has a good standard in place for error handling as well, which is very nice. So, and it's gone through a couple of revisions also. So, for instance, you'll notice that our server reported that it's using JSON-RPC 2.0. Well, that means that I can actually pass parameters in a little bit different fashion. I can pass them basically as a JSON dictionary. So, for instance, the parameters were ival1 and ival2. I can actually reverse the parameters, pass them in any order I want. In a dictionary, and basically it has named parameter support as one of the additions to JSON-RPC 2.0. And so instead of sending it this kind of ordered, unnamed array, which is what I was doing before as parameters, I can actually do named parameters in any order I want, and of course get a result back here very easily. And so, you know, we end up with a situation in this case where with a well-established standard, you know what you're getting into that way. So you can take a look at some of this stuff, you know, if you're interested in JSON-RPC. But you know, the main point to get across here is that we're just using what's out there in this case. So the next thing I wanted to kind of go over here before we move forward is this single service model that we're using. So basically, each evolution.src, if you had multiple services you wanted to run, each service right now is an individual service. You can have one per an application. You can't right now expose multiple services per pool, basically, of an application. We get this one in here. And that was done intentionally. And one of the reasons we did that is that it forces your application to be partitioned in some way. So, for instance, if your application is made up of maybe a session management module and your main functionality module, maybe you have a module related to reporting, these would be separate executables that would basically expose just that functionality. And having these separate pools has some advantages. One is that it forces this modularity in your application, but also it allows you to deal with the situation where part of your application may have a high load and another part may not have as high of a load. So for instance, you can take maybe one piece of your application actually serves stuff onto the web that is going to be accessed tens of thousands, hundreds of thousands of times in in a day or a week or whatever the time frame is, whereas most of the rest of your application isn't going to experience that amount of load. By forcing this separate service per structure, it allows you to set up a pool of processes for one service separate from all the rest that can handle its own load and not affect the responsiveness of another part of your application. So it's very common for us to see this done in other programming languages. They'll do this sort of thing where they'll expose separate services, and it may be that they have one for session management, another for admin, another for the main structure of the application. So that's this whole idea of just needing really two files to get started here. So the next piece to go over is in relation to how we actually deal with structures. So right now we've just passed primitive data types here. What process will we go through for actual structures? So the way we're going to amend our application here to support that is I'm actually going to copy in some code from our, if you were to take a look at the demo that we have available over here, I'm going to copy some code that was used in this demo application here. So it's not running right now. But we're going to go ahead and copy some of that over. So the structure we're going to deal with first is a customer. And we're actually going to actually grab something from the database here for this next service we're going to expose. And the reason I'm using this this customer example is when we move on to some of our other training sessions where we go over some of the more advanced features, we're actually going to work on building out a demo application that basically our evolution demos is what we're going to work on there. And we're going to expose most of that API. So rather than writing all this code where I know I'm going to make an error, we're gonna copy this code in because there's a few lines in this case. Okay, so we're going to copy in a new function here, and I'll go over it with you guys a little bit. Okay, so we brought in a find customer call, and in this case, the way this one is set up, we can pass in a customer number and then the direction of the find, which this is really kind of exposing something that is, true data flex, where we have our various operators that can be passed as 0, 1, 2, 3, 4. and to determine the direction of the find, you may define an enum for something like that normally. And in this case, we're returning a customer. And this is a very simple call. We come in here and we verify the parameter that's coming in. It's, of course, very important when you're defining APIs that you never trust anything that's coming from the client. So you'll notice in this case, I do a verification check to make sure that the find direction variable is in the supported range. I fail out otherwise. Very important that you do this in all API calls, that you deal with ranges properly, with parameters, the way you use them. We'll be going into that in a future webinar in more detail. But essentially here, finding a customer, I'm using the vfind command so I can do it very dynamically. And basically I'm loading up that customer's data into this structure, and then I'm just returning it. So we'll go ahead and run this. And then we're going to come over here. And we're going to test this out. So find customer was the call. Our parameters are customer number. Now you'll notice in my code, customer number is uppercased, properly cased over here. And over here I'm defining everything in lowercase. Part of the side effect of the way some of this is processed is that everything, DataFlex isn't case sensitive, as we all know. So in this case, everything ends up getting processed as lowercase. So even if you define it with some sort of camel casing or anything like that, because DataFlex isn't case sensitive, it all ends up compiled to lowercase anyways. So just an item to know there. So we're going to use the Json-Rpc 2.0 calling style. So we have a customer number, and we have find direction. And we're going to do 2, which is find equal. And I think 98 is probably a valid customer. Yeah, here we go. So this is essentially all it takes to pass structures. It's a very, very simple process. You can see in our result value here, essentially we got back that structure just as we had defined it, and it looks very similar to the parameters. This is how JSON structures are passed in this way. It's very simple, very easy to use, and like I said, there's not much to it. This tool ends up making it real easy to test your code as well. And so when you're working with structures, one of the things that we're going to spend a lot of time on in a future webinar is how to design your structures, not just for reading, but also for passing data back into your application. That's an area we're going to spend almost an entire session focusing on, is designing these structures in certain fashions. So as you can see here, Evolution has a real simple interface for dealing with not only primitive types but also structures. Arrays are supported, and you can return structures. They can be passed in as parameters also just as easily. And in fact, when we look at the type support for Evolution, basically we have support for almost all of the primitives that you would use in DataFlex regularly. For instance, about the only limitations that way really are that you can't pass variants. We need to know the data type, and pointers and handles, of course, also don't pass over the web in any usable format, so they aren't supported as well. But you have support for arrays and structures. There is a limitation in relation to recursive structures. Right now, we don't have support for recursive structures. But the one limitation that you may be thinking about here is when I mentioned that no variants can be used. In fact, internally, we make pretty extensive use of variants. You know, if you were to look at our packages, you'd see some of that. But we don't support passing variants, and really that's due to the fact that when you're using evolution, if you're using it with Thrift, for instance, in comparison to the Json-Rpc side of things, lots of other languages are very strongly typed, and they need to know what to expect over the over this remote procedure call. And so, to give us the broadest language support, we made evolution a strongly typed system rather than a weakly typed system. Now, VF is very classically kind of an in-between language. It's most people would consider it weakly typed because you can do things like move 10 to ival, right? Where you move a string value into an integer and it works just fine. That would be a loosely typed example there. And those sorts of things, although they can be very useful, they also have some side effects to them from the standpoint of how you process types that basically gets very complex and sometimes impossible when we're crossing language boundaries. And a good example of that, if we publish one more call here, and add in one more down here. Oh. Outside of the function. We're going to do a test date function. And this is an area, so here, let's just go ahead and run it first, and then we'll talk about it a bit.
Oliver?
Yes.
Yeah, a couple of remarks here. Somebody's we are getting this proxy error on evolution.mertechdata.com. You're looking into that? Or somebody's looking into that, or?
Aaron, if you're listening, maybe you can take a look at that for me.
Okay. The other is a comment from Will about the find direction validation check should become a default function in evolution. I think you don't need to reply, just just a comment. Okay.
Yeah, so some of that stuff, there's lots of areas of extension that we can do that way. It kind of depends on how you're going to use these calls. In other words, this whole idea of a find direction, a lot of times actually isn't that useful. We actually added this in after the fact. So some of that stuff, yeah, is very easy to do. There's lots of areas where we can tweak stuff that way. So definitely give us that feedback, and we'll look at what we can do on some of those things. Okay, so on our test state call here, you can see I did our test state call, and you'll notice that our call here is not my current time. It's off quite a bit from my current time. Well, you'll notice we're passing everything in this case in UTC time. And dates are one of the things that's really difficult to work with when we cross language boundaries because they're represented in so many different ways in different languages. And so this alone was one of the reasons we had to really give some thought to how we handle typing in evolution. And in fact, we had to do some pretty extensive work that we'll go into in the next section, specifically with dates to work with the web. When you're using any of these various frameworks out there, there are some concerns in relation to how dates are handled. You'll notice that the date is essentially a string here also. There isn't a standard in Json-Rpc or in any other web protocols really that other than SOAP that define date, and so we're using a definition of it here. And so, anyways, dates are a good example for us of how this works. Now, one of the other things that I wanted to point out here is this ID. When a request is made through Json-Rpc, one of the things that is mandated is that a unique ID is passed on each call, and then the result value has that ID embedded in it. And it can be a very useful thing if you have a multi-threaded sort of front end that is making calls to a Json-Rpc server where it needs to track its results specifically in comparison to just any result coming back. Since, of course, in a non-blocking server like Evolution, they can come back in a different order than the requests were made based on how they were processed. So if you see this ID, that's what that's related to. Okay, so the next area we're going to talk about in relation to this is how do we go about testing our API. So I want to give you guys a little bit more information about this tool that we're using here. This is a publicly available tool. API.org is the website for it, and in fact, this is a working test server, or a working example of it right here, right on their website even. Right from their homepage, you can call functions on our internal server here that I have running right now, because this tool actually, it doesn't go out and use some third-party server. It actually uses, it contacts whatever URL you put in here natively, locally. And it's a really useful tool because it can also handle raw JSON requests. It can handle XML-RPC along with SOAP 1.1 and 1.2. And basically it shows you the return value just as it comes back. So if I go look at the raw value of the request, I can see exactly what my request looked like. But I'm specifying JSON-RPC to the parameters in this case, and exactly what the response is. And very useful tool for you for lots of cases. And in fact, what a lot of companies do if you're going to be developing an extensive API, let's see here, is they embed this API into their documentation. So this is kind of a neat one here, just to look at, to show you some of the things that can be done. So, for instance, this is a CRM application, and this is the documentation for their API that they expose. And this just to give you an idea of some of the things that can be done. So they have a very simple call here, and they actually embed right in their documentation the ability to test and make calls to their server. When you're developing an API, that's the sort of thing that you may need to provide to either the web developer or the company that's consuming your API. And this tool is kind of meant for doing that sort of stuff, and it's available under this very broad license, the MIT software license, which allows you to embed it in your software. That's why it's one of the reasons that we include it in Evolution. And in fact, we're going to show some of that now. So as I had mentioned, we have this Apache server here, and one of the things that we threw in here, I'm going to go ahead and just run our start Apache, and you'll notice it's giving me the same message that it needs to get on access support there. And what we're going to do is we're just going to go to localhost. Now, our server for Evolution is exposing that API on port 8081. Localhost, just on port 80, which is the default, is now running our Apache server, and that Apache server has API baked into it. So right as part of the installation, even if your web access is down or you don't want to do the call using that, we throw API directly into the Evolution installer so that you can use it right from here. And it'll call your local server. So this is one of the...
Just a clarification. Sorry, as a clarification. So the Evolution installation also installed Apache?
Correct. We installed a version of Apache meant for development. And like I had mentioned, we customized it to make it a little bit easier to use. If you want to start the server, use the start Apache. If you want to stop it, use the stop Apache, and it'll stop that server running. So very simple installation.
How big is the Apache installation total?
It's about 5 megabytes, I believe.
Awesome.
Yeah, so it's a very modularized one. It still has here if you wanted to run it as a service and all of that sort of stuff, but it's just set up to run as a simple application right now. And we're actually hoping, to make this even easier to use in the future. So it's one of the areas we've been working on. So this is one of the tools that I use, but I wanted to show you guys another tool that we use for testing API calls. And this is called Charles Proxy. And this is a paid application, but it's extremely powerful application. Basically, this is going to watch all web traffic that's occurring on my machine and give me tons of details about all of that traffic as its most basic functionality, just at the most basic level. So to give you an example, I'm going to open up a tab and go to localhost. And you'll notice, even right now, you'll see, I've got some stuff in here that's occurred. So I'm going to go in here and do our test evolution call. And okay, so I did my call here, and of course I could go in on here and look at the raw call, and you see that just kind of the way we showed it before. But in fact, there's a little bit more going on here, and this is where an application like Charles really comes in handy. You'll notice under here I actually have 2 calls that have occurred when I made this. Let's look at both of these calls. The first one here, notice the method that was called, options. So one of the things you may have heard of, it's been mentioned in the forums on a couple of occasions, is CORS, cross-origin resource sharing. And this is the concept that basically the browser limits your ability to use resources on a different domain for security reasons. And a lot of times you may actually need to access a different domain validly. The way that you're allowed to do that on the web is by way of cross-origin resource sharing. And basically the way it works is that the browser here, when I go to make a call to localhost 8081 on port 8081, that's considered different than localhost. Even a different port number breaks the cross-origin resource policy. And so the browser silently sends a request to this server and says an options request. And basically it's asking that server if it's okay that this, if we look at the request in detail, you'll see this referrer listed. Is it okay that this referrer accesses your server? And Evolution has cross-origin resource sharing built in. And so it sees this options tag and replies that it's fine that, in this case, any domain is the way it's set up, can access this API. And so it responds to that options request. Once the browser has authenticated that it's okay for this to occur, then we get our actual call. So if we go and look at our overview, here's our actual post, and we can look at the request that went over, and it looks very similar to what we see back in here. We see this ID that came through, and then we can take a look at the response, and of course you can see the response here as well. And one of the nice things about Charles is that it gives you a lot of timing information. So for instance, it shows that my call took, it could only time it down to millisecond, but it shows you the exact size of the response and the request along with the total size. So lots of good details that way. And in fact, it does quite a few other things. You can record sequences of calls and save them off and play them back to look for common responses, so it can be used almost as like a unit testing utility. And you can even have it respond as if it is the server and block requests to the server, so that you can use this as kind of like a fake server to try out various things. And that's just scratching the surface of what this application does. It's a very useful one. It pairs very nicely with Evolution's functionality. So we use it quite a bit when we're working on Evolution applications. Okay, so the next item we want to talk about is this Apache integration a little bit more. So in this case, I'm using this utility with Apache, but I'm calling the Evolution server directly. There, of course, is the cross-origin resource sharing issue in relation to this. There's SSL. If you needed to make your API secure, there's SSL issues. There's all kinds of things that make this great for testing, but not necessarily all that great for if you wanted to, take this live. And the way we've handled this is by way of Apache's reverse proxy. So essentially, a reverse proxy is a situation where Apache sits in front of an application server or a group of application servers, and the client only ever contacts the Apache server, and it forwards a request onto the application servers, and then gets a request and passes it back to the client. Now, even in this developer setup, we've made it really easy to try out this reverse proxy. So we're going to go ahead and set up Apache to use this reverse proxy. So we're going to go into our configuration folder, and we are going to use Notepad++. First things first, though, we're going to go and stop our Apache server temporarily. And the Apache configuration file, just a text file, very easy to use. And this is not completely the default file. We've customized it a little bit. For instance, we've tweaked some of the stuff related to the root so that it can be passed, so that you can, one of the things that we give you here is this Apache folder. We put it under the root of C, but you could very easily take this Apache folder and put it under your application folder. It will work from anywhere, and it's configured. One of the customizations we made is for it to know where it is and how to serve files in its main folder from anywhere. So it's pretty smart that way. You can move it around if you don't want it in the root of C, and it'll work just fine. Some of the other customizations we made was kind of adjusting some of the modules that are loaded here for the things that for Evolution-style applications you may want to load. We also, for now, got rid of the SSL module. But we can go over that a little bit later. Okay, so down after all the module loading, some of the modules that are in here are related to this reverse proxy service. And so what we're going to customize is after that. And essentially, to set up a proxy for Evolution, we only have one line. That's all we need. We set up a path so that on whatever port Apache is running on, so port 80, the order entry path gets forwarded and the response gets returned through localhost 8081. That's it. If I go and save this now and start up our server, I can still call on port 8081. That'll work if I go in here and change this. That's still going to return a value. But now I can also call over here. And you'll notice my request looks a little different now. I've called, basically, we have a reverse proxy set up now, and part of what that does is it Apache adds in some of its own headers into this. So we've gotten the server header that came in here. We've got some keep alive information, all things that Apache handles, which can be very useful to have, get thrown into this request, and basically they amend the request with these additional headers. But our results, as you can see, we're doing our request to our evolution server. It's that simple with Apache. And in fact, there's if you have a little bit different situation where maybe you're wanting to do load balancing or something like that, that's also just equally as easy. I'm going to show you. I don't have all of the hardware set up for it, but we're going to put in an actual example from another machine that I have. Copy this in here. So we were to mark out that line and paste in this little block. Let's say that you had 2 evolution servers running and you wanted to balance the load between those 2 servers. Essentially, I define a balancer proxy using this syntax here. I define my member, which is just the IP address and port number of the evolution server. And I've got a second server in this case, and then I tell it that instead of passing the proxy, I would normally have like order entry here. Instead of proxying to a single server, I proxy to the cluster in this case, or the balanced load. And that's all there is to it. Now, this actually has lots of options that are available for it once you start going down this path. So, for instance, you can use Apache just with reverse proxy to add SSL into evolution. You know, it can serve as an SSL front end. It'll decrypt the data, pass it on to a private evolution server, and then re-encrypt the output for the client. So basically inserting SSL along the way. Very easy to do. All you have to do is set up SSL and it will just work. With this clustering and load balancing, you have tons of options about how that actually works. Load balancing can be set up based on busyness of the server. It can be set up based on a percentage share, so you can say, well, this server is twice as powerful as this one, so I want this one to handle 75% and this one to handle 25%, something to that effect. Or even by the amount of bytes of traffic that are moving back and forth over the server. There's just a huge number of options that way based on what your setup is that can be changed very easily. They're just text options in your config file. One of the other things that Apache handles for you when you're doing this load balancing is what's called connection stickiness. So one of the very simple optimizations that you may want to have is when a client does an API call to the server, you may want that same client, when it calls the server again, to access the same backend server if you had multiple servers running. That sort of stickiness, Apache has all of that built in. It's very easy to implement. The nice thing also, of course, is that this is all industry standard. There's lots of documentation, lots of help available for it from many sources. So you know, it's really nice to use this along with evolution because you have so many other resources that become available to you when Apache's in the mix.
So Oliver, I have a comment here from Will. He says, if reverse proxy works, then I think you should also use things like Redis or Varnish with evolution to speed things up.
Yeah, definitely something like Varnish. Those sorts of utilities that can basically handle some in-between caching of connections and things like that will definitely work. And in fact, when we get to some of the webinars related to more advanced deployments, if you were deploying maybe a SaaS style application or something like that, we'll dig into some of those issues and show some of that off. but yeah, all of that there's just, some of you may not have heard of these utilities before, these applications before, but there's just a huge community around Apache that offers tons of features for any given scenario, whether you want to have extensive caching in there, like a memcache setup or something like that. There's just so many options available. And so we're going to dig into some of the more popular ones in the future for sure. One of the other things I wanted to mention along with this, because this is set up to work with reverse proxying, it means that you can use any front-end server along with evolution. IIS, for instance, maybe you are an IIS shop already and are very familiar with it. Since evolution is just a very fast API server working in this mode, there's no reason that IIS can't be used as your front-end proxy as well. The setup is a little bit more extensive with IIS for how you have to do proxying, so I'm not going to go through the whole thing, but we will certainly give you the some URLs for how you can set it up. There is some stuff related to load balancing with IIS, but there's also some utilities. There's one out there called Kemp that is basically customized to work as a load balancer for IIS, and of course, Evolution can sit behind other load balancers as well. Any of the commercial load balancers could be used as front-end servers for Evolution without a problem at all. And so rather than building our own sort of load balancing mechanism, what we're doing is allowing you to use what's already out there, and in a lot of cases is free, to use with your application, rather than trying to roll our own. When you do use it with IIS, you have a URL rewrite module. There's another module that they mention in here called the application request routing. That's required as well. Here it is, application request routing. And there's this whole concept of a web platform installer that is available for IIS that helps you with some of these things. Just to let you know, Apache is quite a bit faster even than IIS when we've done some testing. IIS performance isn't bad, but especially when you're looking at proxying, Apache really cleans up well. And of course, there's no reason that the front-end server even needs to be on Windows. This could just as easily be the same configuration file essentially with Apache on a Linux box. Nothing is limiting us to Windows in this case. So the last section I wanted to go over here is how you deal with debugging in just some very basic debugging in Evolution. And really that's the use cases for it. What we found is most useful. One is just making use of the Dataflex debugger. So if I put a stop point in and go over here and call find customer, and in this case I'm not just kind of cheat and use the old protocol that and send it. I got a stop point right in my application here, and I can take a look at what came in. I could tweak stuff in here. Basically, you can use the Dataflex debugger as is. And so, that all just works in here just fine. And in fact, when you're using Evolution right now with this first beta, you're going to want to use it in the debugger 100% of the time because we've set it up to serve on that specific port and all of those things only while in debug mode. So for now, it is kind of set up to work that way. So keep an eye out for that. I can go ahead and just continue this and come back here, and you'll see we reached a timeout. And that's one of the things that you have to be aware of with some of this, is that a lot of times there's pretty short timeouts. They may be are 5 seconds, somewhere in there, and that depends on what this utility is set up to use. But of course, being able to use the DataFlex debugger is very nice. Charles is the other option that we really wanted to mention that way. Most of the time, whenever I'm talking to my developers, whether it's using Evolution or using some other web technology, there's the one thing I harp on over and over again is, what does the data look like? What are we seeing over the line? And that's where something like Charles and API is very useful, because it lets me see everything about the request. And most of the time when you're working with an API call, your problem is visible. If it's done in something like JSON or Json-Rpc, it's normally something that you can just take a look at and see what's wrong with very easily. And I can't really emphasize this enough, that using these utilities to look at what is actually going over the line is the best way to debug them in most cases. Having access to the debugger is great. You can step through your code, look at return values, but actually seeing how it's getting formatted will show you if there's problems with character encoding, or you know, whether a parameter was passed with you know, inside of a JSON object when it shouldn't have been, things like that. Using these utilities for that is really how you're going to be most efficient while building your API. So this is basically what we wanted to go over to get you guys started with Evolution, but I do want to let you know what's coming next, and then of course if people have questions, you know, you're welcome to ask them. The next webinar is actually a part 1 of 2 on API training, and we're going to be focused on basically building out our order entry example with an ORM or document-based model for an API, and we're going to go over all the details of how you design a document-based interface to an application. So we're going to go over that in detail, and in fact, this first piece of code that we put in here is one of the first items that we're going to be talking about more extensively in our next section. Another area we're going to go over is localization, where we talk about, especially if you're building something that's going to be used as a SaaS, how you localize that so that your application maybe is hosted in one data center or a couple of data centers in various places, and you need to have localization support for all over the world possibly. So we'll spend some time on that. And then the next piece that's coming in part 1 is dealing with essentially returning lists of data. So whether that's fulfilling a grid or just a standard list or something like that, there's lots of different methods we can use depending on how you think your front end is going to be consumed, and we're going to go over each one of those in detail. So that's kind of what's coming up next, and that webinar is scheduled for 2 weeks from now. Of course, hopefully you can take a look at the Evolution demo that's available here. There we go, it's back up now. Basically, we're going to go through what it takes to build a lot of what was required for this application here. So all of the API for it, and then eventually we're going to be doing a webinar where we talk about how we built some of this front end to attach to that API. The front end was built by an individual that did not build the back end. You know, I worked with someone to build the API interface, and we had a front end designer build all of this interface for it. So, you know, it really is a good demonstration of this concept of the separation of duties in relation to web application development. So that's some of the things that we have coming up. I'd love to hear any questions you have, anything maybe I went over too fast or wanted to see again. I do want to mention also that we'd love to get your feedback on this, not only on this webinar, but also on the actual beta. Hopefully, you guys have were able to download it and follow along somewhat on some of these things and test out some of these calls. If you come across anything, of course it's beta. I expect you guys to find some issues along the way. Feel free to email those over to us, and those can be, for now, those can just be emailed directly to me at oliverin@mertechdata.com.
All right. So recording for this training will be available in a few days, and also the some of the source code that Oliver showed will make that available as well.
Okay. Well, if there's no other questions, we'll let you guys get back to it, and in a couple of weeks' time, we'll be ready to go over our big section on APIs in a lot more detail here with Evolution. Thank you guys for joining us this morning.